Next lesson in our SAT coverage is we're going to look at graphs of linear equations and functions. So again, recall that linear equations and functions form a straight line on the xy plane. Here we can see the equation y equals 2x minus 1 graphed on the plane to the left. And if we're dealing with functions, instead of using y to represent our output, we use function notation. But they are synonymous and they serve essentially the same concept or the same function. So we can see various features of a linear function by looking at a graph. We can see slope pretty quickly and get an idea for what the rate of change is. We can also see the x and y intercepts pretty easily from the graph. So looking at the graph here, that's shown on the left of f of x equals 2x minus 1, we can look at the slope and see that for any two given points for the slope, we can identify the rise over the run, the change in the x, or the change in y over the change in x. And we see that for every 2 units that y increases, x increases by 1 unit. So we get a slope of 2. We can also look at some of our intercepts. When we look at where we intercept the y-axis, we see that our y-intercept is located at the point 0, negative 1, and our x-intercept appears to be located at the point 1/2, 0. And so we can identify some features of our function pretty quickly when we're given a graph. So we've got the ratio of the line's change in y to its change in x. That gives us our slope. It describes the direction and the steepness of a line. A line that trends upward from left to right is considered to have a positive slope, while a trend that is downward from left to right is considered to have a negative slope. The steeper the line, the larger the magnitude. So a line with a slope of 2 is shown here, but if I had a line with a slope of 1/2, it would be less steep than the one shown. So here's our nice formula for slope that we've already used before, but it's good to have as a reminder. Some special things about slope to remember. Horizontal lines will always have a slope of 0, because all points have the same y coordinate. Therefore, the change in y is always 0. If my change in y is 0 over any value, doesn't matter, it will always be 0. However, our vertical lines have an undefined slope because the change in x is always 0. So regardless of what y is, anything divided by 0 is always undefined. So we have those special values within our slope. So given a couple examples involving slope, line L contains the point -1, 2, and 4, 12. We want to find the slope of the line. So again, we just use our slope formula. 12 minus 2, we've got x1 and y1, x2 and y2. So we've got 12 minus 2 over 4 minus -1. And that gives us 10 over 5 for a slope of 2. So we found the slope of line L. If we're trying to find slope on the line graphed, we can look again, pick 2 points that are easy to identify in the graph, and identify the change in the y compared to the change in the x. So to get from point 1 to point 2, we have to go down 3 units and right 2 units. So we'll go down 3 and right 2, giving us a slope of -3 over 2. We could also use the ordered pairs that are here with our slope formula to reach the same conclusion. The points 0, 3, as well as 2, 0. We can plug in y2 minus y1 over x2 minus x1, and we end up getting the same exact value. Next key feature of graph we're going to look at are the intercepts. The x-intercept is the coordinate when y equals 0, and the point on the graph where we cross the x-axis. Y-intercept is the coordinate when x equals 0, the point where the graph crosses the y-axis. See, these things are named pretty simply. We don't name things in mathematics clever or try to trick you. We tend to name them for what they are. The x-intercept is where we intercept the x-axis, and like for the y. So if we want to find x and y intercepts, we can look at the line graphed above, and we want to identify what is the coordinate when y equals 0. So we look at our y-axis here, and we see that this is the point where we crossed the y-axis at the point 0, 3. So the y-intercept is the point 0, 3. And if we look at our x-axis, and we want to look to see where it crossed the line, and we see at the point 2, 0 is where our x-intercept is located. Pretty basic, simple linear equations. Now, if we're not given a graph or given points, how can we find slope as well as x and y intercept of the equations, and specifically when we're given different forms of the equation? So we'll start with A, and we're given the equation y equals 2x minus 1, which is in the form of y equals mx plus b. Well, the benefit of this is it tells us two things right away. It tells us the slope, and it tells us the y-intercept. So those two pieces of information are given really quickly. So we already know that our slope is equal to m, which in this case is 2. And we know that our y-intercept is going to be the point where x is 0 and the b value of our equation. So the y-intercept is located at 0, negative 1. 0b, which in this case is 0, negative 1. So the only thing we have to do is solve for the x-intercept. So the x-intercept will be the point value x where y is 0. So all we have to do is take our equation and substitute in 0 for y and solve for x. So we can go ahead and isolate. 1 will equal 2x, and x will equal 1/2. So we have our ordered pair for the x-intercept as 1/2, 0. Next, we have something very similar, but now it's in function notation. But remember, function notation still models that y equals mx plus b structure. So again, we're given our slope as 3, and we're given our y-intercept as 0, negative 7. So all we have to do is find our x-intercept. Substitute in 0 for the function, where y would be located. And then we can go ahead and work towards solving for x. So x equals 7/3, giving us an x-intercept of 7/3, 0. Now we've got an equation written in standard form, ax plus by equals c. And if you recall from a previous lesson, ax plus by equals c, standard form is really useful for finding x and y intercepts because it actually works really quickly. So first what we're going to do is we'll start with our x-intercept. Again, x-intercept is when y equals 0. So if we take 4x plus 5 and we replace the y with 0, what actually happens is that we can cancel out this term and we're left with just 4x equals 20. And from here, it's just a one-step equation. We just divide both sides by 4. X equals 5. We have our x-intercept of 5, 0. Y-intercept is going to follow the same trend. But instead of canceling out the y term in 4x plus 5y equals 20, we're actually going to cancel out the x term, leaving us with 5y plus 20. So when we divide both sides by 5, we end up with y equals 4. So we have our y-intercept of 0, 4. X and y-intercept are really quickly defined when we're given an equation in slope-intercept form. And then in order to find, or I'm sorry, in standard form. And then when we're looking to find our slope, it's a quick rewrite into slope-intercept form in order to get our equation. And it's actually going to be a common pattern that you'll see a lot in standard form. But when we start with 4x plus 5y equals 20, we want to isolate y. We get 5y equals negative 4x plus 20. And then we divide everything by 5. We get y equals negative 4/5 x plus 4. And then our slope is shown by the m value in slope-intercept form. So a lot of times when we're in standard form, what we can look at is that the slope from standard form will actually be the ratio. It'll be the ratio of the opposite of A over B. The opposite of A over B will be our slope if we were to rewrite it into slope-intercept form. And so if you remember that little trick, finding slope from standard form is not going to be that hard either. Lastly, again, we got another one in standard form. We can find the slope and the x and y intercepts. So again, for the x-intercept, we cancel out the y term. So we're left with 3x equals 12, x equals 4. So we have the ordered pair 4, 0. To find the y-intercept, cancel out the x term. Negative 4y equals 12, y equals negative 3, 0, negative 3 for the y-intercept, 0, 3. And then for slope, we're going to have the ratio, again, of the opposite of negative a over b. Okay, so the opposite of a is negative 3, b is negative 4, so our slope is just going to be 3/4. So we can find those three values quite quickly. Next, we'll look at kind of going in the other direction, and we want to write an equation given specific features of our line. If we know either the slope of the line and a point, or 2 points on the line, we can write a linear equation. If we know 2 points of the line, we can find the slope, and what we really need for the equation is specifically a slope and a point. If a line A has a slope of 2 and passes through the point 1, 3, what is the equation of line A? Now, there's a couple different ways to approach this. I have a preference of method 2, but a lot of students prefer method 1 because it's easier to remember the equation that you use. But again, I'm all about saving time, and I can do it a little bit faster using method 2. So we're going to go ahead and show both methods here. So in method 1, in order to write an equation, we need slope and we need intercept. So we can start with y equals mx plus b. We're given slope and a point, and we can solve for b just like we did in an earlier lesson. So we can put in with y equals mx plus b our slope as well as the x and y value of the given point. 3 equals 2 times 1 plus b. And then we will go ahead and solve for b. And so we're given a b value of 1, and then we can go ahead and rewrite it back into our equation, plugging in slope and 1 for our y-intercept. Now that was pretty quick. I will admit it is a fast process. If the points or the slope have some negative values, or maybe they're fractions or decimals, it might take a little bit longer. So keep that in mind. But this is a very straightforward method that you can use. The second method that I do prefer, because I think more consistently it's faster, is using the point-slope form of an equation. Now, point-slope form is actually not that hard of an equation to remember, because it's derived from our formula for slope. Recall that slope is m equals y2 minus y1 over x2 minus x1. Well, if I take this entire denominator of x2 minus x1, and I multiply both sides of my equation by that denominator, so that it cancels here, what I'm left with is x2 minus x1 times m equals y2 minus y1. And that looks markedly similar to what we have here. The only difference is we don't have the x2 and the y2, and they're on different sides of the equal sign. But that's where we get the equation for point-slope form. It's derived from one from the other. And so given this, we don't need to find the y-intercept. It's going to happen as a side effect of just solving the equation for y. And so what we do is we start with our y value, and then the y value that's given, in this case, is 3. And so we write as y minus 3 equals, again, the slope that is given, our x value minus the x value that is given, which in this case was 1. And so now all I have to do is solve this equation for y, and I have my equation in slope-intercept form. And so we'll do two things. First is we will distribute the 2, and we will go ahead and add the 3. And in one last step, or approximately the same amount of steps, we end up with our equation in slope-intercept form. So you can choose which method you want. I will not be offended either way. I just prefer point-slope form because I know it's going to get me into the right form fastest, more consistently. Now, given 2 points, if a line B passes through the given points, what is the equation of line B? Generally, with this case, then we're going to want to find the slope first and then use either of the 2 methods that are shown above. So we'll start with by finding our slope, y2 minus y1 over x2 minus x1. So we get a slope of negative 9 over 3, which is negative 3. And then I'm going to go ahead and use point slope form again. Y minus y1 equals mx minus x1. If you want to use slope-intercept form, I encourage you to pause and try it on your own and see if you end up with the same solution as I, and how many steps it took you to do it. Again, I will not be offended either way. So I'm going to pick a point. I'm going to use this one. We don't need to use both. We just need one point as well as our slope. So we have y minus 4 equals our slope times x minus negative 2, or plus 2. And so we'll go ahead and distribute. Y minus 4 equals negative 3x minus 6. And then we'll add 4 to end with y equals negative 3x minus 2. There's our equation there. Given the graph, we'll want to identify, again, slope and y-intercept if we can, in order to write our equation. Otherwise, we're going to have to use one of the methods above in order to solve. So given the first equation, we can look and notice that, all right, we've got the y-intercept plotted here at the point 0, negative 4. So we know that b will equal negative 4. And then we can identify our slope by starting here and going up to another part where we cross the line. And so we see that we can have a change in y of 3 and a change in x of 1. So if our slope is 3 over 1, that's just simply 3. Our y-intercept is 0, negative 4. 0, 4. So y equals 3x minus 4 for our linear equation. Now in our second example, we don't have the y-intercept. It's somewhere up here, and we don't know what that value is. So we'll need to use an equation in order to solve it. But we do have a couple points, and we can identify our slope. So pick 2 points on the line that are easy to graph. Down to right 1 for our slope. Down to right 1, so our slope is negative 2. And then we can go ahead and use point-slope form or slope-intercept form. We'll use the point that is the x-intercept down here, 5, 0. Y minus 0 equals negative 2, x minus 5. Since it's minus 0, we actually don't have to do anything with that. The only thing we need to do is distribute. And we have our equation in slope-intercept form. Last thing we're going to cover is parallel and perpendicular lines. In the xy planes, lines with different slopes will intersect exactly one time. Now, the only time lines will not intersect is when they have the exact same slope, and we call those parallel lines. Two lines in the xy plane with the same slope, they will not intersect unless they completely overlap. So lines L and M here are parallel. L and M here are parallel because line L and line M both have a slope of 2, and they do not overlap. Line N is not parallel to either L or M. We can see that it intersects. Perpendicular lines are when the slope of two lines have opposite and reciprocal slopes. That means that we change the sign, and flip the fraction. And so we see that if we have a slope of 2, if we change the sign and make it -2 over 1, and then flip the fraction, we get -1/2. Therefore, 2 and -1/2 are reciprocals. Because line N has the slope of -1/2, it is perpendicular to both of the two lines shown here. And so given whether we're trying to identify parallel perpendicular lines or we're trying to find equations that have parallel and perpendicular lines, the first thing we need to do is identify what is the parallel or perpendicular slope. So we're going to pretend that we have three lines, P, Q, and R, graphed on the xy plane. The equation for line P is given by y equals -3 plus 2. So the slope for line P is -3, given by the equation. Line Q is parallel. Therefore, if it's parallel, it needs to have the same slope. But line R is perpendicular. Therefore, it needs to have a perpendicular slope. So the slope, we need to change the sign to get the opposite, and we need to flip the fraction to get the reciprocal. So when we take the slope of -3 and change the sign, the opposite is 3, and its reciprocal is 1/3. So the slope of line R is 1/3. So now that we're given the slope, we can use our previous methods to write equations for both of these lines, given that they both will pass through the point -3, 11. So let's go ahead and find both of those lines. Again, I like point slope form. Y minus y1 equals mx minus x1. So that's going to be the same for both of them except for the slope. And so the y value is going to be 11. Y minus 11 equals the slope times x plus 3, because that's minus -3. Minus -3 gives us plus 3. We will distribute -3x minus 9, and then we'll add 11 to get -3x plus 2. There's our equation in slope-intercept form. We'll do the same thing over here. Y minus 11 equals 1/3 x plus 3. We will distribute y minus 11 equals 1/3 x plus 1. And then we'll add 11, 1/3 x plus 12 to get our perpendicular line. Perpendicular line R and parallel line